Hi everyone, today we have a very easy and important topic, which is the complement. You can have any complement for different systems, like we can have complement in binary system, decimal system, or octal, and also like any other systems. So in binary system, we're dealing with two types of complement: ones complement and twos complement. The ones complement and twos complements are representation of negative numbers. So in binary system we have negative numbers and positive numbers. For the positive numbers we call them like our integers numbers or unsigned numbers, and for the negative numbers we can call them sign numbers, like because they have a sign. They are not only positive numbers, they can be negative numbers. And how can we represent negative numbers in binary system? 0 represent positive numbers. So here in the most significant bit we call it our sign bit, and for the sign bit it holds a value of 0, and that means that this number is a positive number when we are dealing with the sign numbers. And the negative sign is represented using 1, and here this is our sign bit. And as you can see here, for negative 5 we're using here 1, but for the 5 positive 5 we're filling this sign bit with 0. So this is the difference between signed number and unsigned number. And also you can represent negative numbers in binary system in other way, like using ones complement and twos complement. For the ones complement it's very easy because you're just changing ones to zeros in the number, and like vice versa, ones to zeros and zeros to ones. So here previously we had the representation of 5, positive 5, 0, 1, 0, 1. Then for the ones complement, for the negative 5, like when we want to represent negative 5 but using ones complement, here we're changing every 1 in the positive number to 0 and every 0 to 1. So as you can see here, the 1 became 0 and the 0 became 1, and so on. So for the second thing we have here in this video is twos complement. Twos complement is really easy, but keep in mind that you can't get twos complement unless you find the ones complement of the number. And we deal with ones complement and twos complement to avoid the borrow in the subtraction operation. So we deal only with addition, but we use the twos complement and ones complement for negative numbers. So if you want to get the twos complement of negative 5, you will take the ones complement of the number. Let me write this rule here. Twos complement of the number is equal to ones complement of the number plus 1. So you take this result, which is 1 0 1 0 1 0 1 0, and we add a 1 for the number, which is the ones complement, and then we get our twos complement. So the twos complement for negative 5 is 1 0 1 1. As you can see here, we have 1, which is indicate that this number is a negative number. Also here we had 1 because you are flipping the ones to zeros, and here we have a positive number, so for the sign bit we have 0, then we change it, so it became 1. So that's it for the 2's complement and 1's complement in binary number system. And now we're going to have an example to practice, because sometimes they might ask you to get the 2's complement of the number but using a specific number of bits. So now we have 27, and when the question like ask you for the 2's complement, that means that you're dealing with negative 27. So negative 27, first we will convert 27 from decimal number to binary system, but using 8 bits. So here's our first bit, and here we have our 8 bits starting from 2 power 0 up to 2 power 7, and each time we keep incrementing the power until we reach our most significant bit. Then for this part we have 128, let me erase this, and 64 here, 32, 16, 8, 4, 2 and 1. And now as 27 is less than 128, so let's fill this one with 0. Same for 64 and 32. But 16 is less than 27, so we'll fill this one with 1, and then 27 minus 16 will give us 11. 11 is also greater than 8. Then 11 minus 8, you'll get 3. 3 actually is less than 4, so we will fill this bit with 0. Then 3 is greater than 2, fill it with 1. 3 minus 2 will give us 1. So the value of the bit and the value of the remaining number are the same, so you fill the bit with 1. So now we have the representation of 27 using 8 bits in binary system. And now we want to find the 2's complement. To find the 2's complement, we should find first the 1's complement to find the 2's complement later. As I told you previously that you can't get the 1's complement, the 2's complement directly. You should find the 2's complement and then you add for the 2's complement 1, and then you'll get your 2's complement for the number. So here the 1 will be 0, and same here. Then the 0 will become 1, 1 will become 0, same here, and the remaining 3 bits will be 1s because they are 0s, and we said that 0s will become 1s and 1s will become 0s. Now we have here our 1's complement. And how to get the 2's complement? Just add 1 for the number. Now we have 1, 1, 1, 0, 0, 1, 0, 1. So this is our 2's complement of negative 27. And that's it for binary system. Now also you can also have complement in decimal system, complement in octal, complement in any system. And the basic rule of the complement that we have here in digital logic design or even computer architecture is that the first complement, which we can say that is equivalent to 1's complement, is r minus 1. R here is the base of the number of the system. Like for example, in decimal system our base is 10, so 10 minus 1, our first complement is 9 complement. Then we have r complement, so we have 9's complement and 10's complement. Same for octal system, we have 7 complement and 8's complement. And even if you had, for example, a base 3 system, base 3 system, you will have also the same, like 3's complement and 2's complement. So now let me explain for you how can you obtain the 9's complement of any number. Sorry, this part is really easy because you just need to know how many number you have. So for example, sorry, if you had negative 835 and you want to obtain the 9th complement of the number, or for example even this number, you just for example, if we had 835 and you want to obtain the 9th complement of the number, you just subtract the number from, now you have a number which consists from 3 digits. So here 999, as 9 is our like the greatest number that you can have in this system in any digit. So subtract these and then you'll get 164. So this number is your 9th complement in this system, and the 10th complement, just add for this number 1, you'll get 10th complement. Actually it's the same rule, it's the same concept, but you just apply it for different systems. So this one will be 165. So here is our 10th complement for 835, and 164 is our 9th complement, 10th complement. And the same rule you can apply it for other systems. And also this is like the subtraction that you're doing is the basic rule. Also you can do it binary, but as you know that binary system you only have zeros and ones, so if you subtract 1 from 0 you'll just get the same 1 minus 1. So let's have an example. For example, if we want to get the 2's complement of 3, 1 1 1 1, and we subtract, so this one will be 0 0 1 1. So it's the same like if you are subtracting or you are changing ones to zeros.